Dear student, I will discuss computation by factor level method. It is an excellent method. By means of this, we can solve lot of problems on physics and chemistry by factor level concept. It is a dimensional analysis. From the following simple examples, I will give you clear explanation of factor level method. Now let us start. Sample problem number 1. The density of mercury is 13.6 gram per cubic centimeter. We have to express this density in kg per cubic meter. The solution of this conversion. Require density rho equals to what is given 13.6 gram by 1 cubic centimeter. Density of mercury given 13.6 gram per cubic centimeter. So 13.6 gram by 1 cubic centimeter. Now we need kg per cubic meter. So gram to be converted to kg. What is the conversion factor? Again I will explain. We need kg, so it will appear in the numerator. And the corresponding gram is what? 1000 gram. So gram cancel. So we will have kg. Now we have to convert the cubic centimeter per cubic centimeter to per cubic meter. So we need per cubic meter here, and this will be equals to 10 to the power 6. It is dimensional analysis, cubic centimeter. So you see gram cancel, cubic centimeter cancel. So we will have kg per cubic meter, and if you compute this, it will be 13.6 gram cancel, cubic centimeter cancel. So kg per cubic meter. Answer. Sorry. 3 kg per cubic meter. 13.6 and 10 to the power 6 by 10 to the power 3 means 10 to the power 3 kg per cubic meter. This is the answer. So already we have converted gram per cubic centimeter to kg per cubic meter. Now explanation. Let us see the complete explanation. It is dimensional analysis, you see, dimensionally adjusted. We need kg per cubic meter given gram per cubic centimeter. So first gram cancel by using the conversion factor. 1 kg equals to 1000 gram. So gram to be cancelled out, so this gram will appear in the denominator. Kg required appearing in the numerator. Next we need the what? Per cubic meter. So it is to be cancelled out. So conversion factor is what? We know 1 cubic meter equals to 10 to the power 6 cubic centimeter. So 10 to the power 6 cubic centimeter will appear in the numerator, so that cubic centimeter will be cancelled out and it will survive. So finally we will have kg per cubic meter, because gram cancel, cubic centimeter cancel, and calculate 13.6 10 to the power 6 by 10 to the power 3 kg per cubic meter. The question is more clear explanation. It is dimensional analysis, shortcut technique. We will always follow in this way dimensionally, but you see clear explanation. Rho, density rho equals to, it is given 13.6 gram by 1 cubic centimeter. It is given. Now you see the conversion factor. We have to convert gram into kg. So what the relation we know? 10 to the power cube gram equals to 1 kg, that we know. Now we need gram in the denominator, because it is to be cancelled out. So dividing both sides by what? 10 to the power 3 gram. So we will have what? 1 equals to 1 kg by 10 to the power 3 gram. Now multiply this on both sides. Then you will have this one, this. Multiply this. So this implies 13.6 gram by 1 cubic centimeter into 1 multiplied. Multiplying this on both sides, you know what? 13.6 gram by 1 cubic centimeter into 1 kg by 1000 gram. So you see, so this equals to what? This equals to what? This into this. So I can write this equals to 13.6. This equals to this one. So this equals to this equals to this equals to 13.6 gram by 1 cubic centimeter into 1 kg by 10 to the power cube gram. So gram cancel. We have already obtained kg. Next, cubic centimeter must be cancelled out. We must have cubic centimeter per cubic meter so that we can have kg per cubic meter. So this is to be cancelled. So it will appear in the numerator, and we need cubic meter in the denominator. So it will appear in the denominator. How? Let us see. Again, we know 1 cubic meter equals to 10 to the power 6 cubic centimeter. Now we need cubic meter in the denominator. So dividing both sides by, to get cubic meter in the denominator, dividing both sides by 1 cubic meter. So we'll have 1 equals to 10 to the power 6 cubic centimeter by 1 cubic meter. Now multiply this on both sides. So we'll have this. This is happening. Then we can have merely by dimensional concept, shortcut method. 13.6 gram. This is the explanation. Cubic centimeter 1 kg by 1000 gram into 1. Multiply both sides. Multiply this quantity on both sides. Equal to what? 13.6 gram by 1 cubic centimeter 1 kg by 1000 gram into 10 to the power 6 cubic centimeter by 1 cubic meter. So clearly you see this equals to this quantity, that is this quantity, same quantity, this equals to this. So you can write this equals to 13.6 gram by 1 cubic centimeter 1 kg by 10 to the power 3 gram. This one. That means this one equals to this one. So this into 10 to the power 6 cubic centimeter by 1 cubic meter. You see this quantity, same quantity equals to this one. This quantity equals to this one. And you see our final result. You see rho equals to this one, that one, and that one. And finally you see gram cancel, kg will survive, cubic centimeter cancel, cubic meter in the denominator will survive. So we will have kg per cubic meter and equal, always equal. In CGS unit, gram per cubic centimeter. In SI unit, kg per cubic meter. Calculate 13.6 10 to the power 6 minus 3, so 10 to the power 3 kg per cubic meter. This is the answer. Already explanation is done. It is the first way. You can have shortcut method also. So let us see shortcut. It is complete explanation I have given. Now let us see shortcut method also. By shortcut method. Shortcut method. Density rho given 13.6 gram by 1 cubic centimeter into I can write 1 into 1. Now you see this 1 equals, already you have explained 1. 1 equals to what? 1 kg by 1000 gram. We know 1 kg is equal to 1000 gram. So if we divide by 1000 gram, we can have 1 kg by 1000 gram. Or if we divide by 1 kg, so it will be 1000 gram by 1 kg. But we need gram in the denominator, that's why I have chosen 1 is equal to 1 kg by 1000 gram. Because actually 1000 gram, you see 1000 gram equals to 1 kg. So you can have 1. If you divide both sides by 1000 grams, so 1 equals to 1 kg by 1000 gram. If you like to get 1000 gram by kg, so divide both sides by 1 kg. So we'll have 1 equals to 1000 gram by 1 kg. But we need this conversion factor because gram to be cancelled out and kg will survive. So it will appear in the numerator and gram will appear in the denominator. So here this one is replaced by 1 kg by 1000 gram. Yes. Now this gram. Since 1 to 1 dimensions, there is no change, equality will hold. But next case we need what? We have to cancel cubic centimeter and we need cubic meter in the denominator. So we have this one. Since 1 equals to 10 to the power 6 cubic centimeter by 1 cubic meter, because you know 1 cubic meter equals to 10 to the power 6 cubic centimeter. That you know. So clearly, if you need 1 cubic meter equals to 10 to the power 6 cubic centimeter. If you need cubic meter in the denominator, so divide both sides by 1 cubic meter. So 1 equals to 10 to the power 6 cubic centimeter by 1 cubic meter. If you need cubic centimeter in the denominator, so divide both sides by 10 to the power 6 cubic centimeter. So 1 equals to 10 to the power 1 cubic meter by 10 to the power 6 cubic centimeter. But we need what? We need this one because cubic centimeter will be cancelled out. So it will appear in the numerator. So cubic centimeter will be cancelled out. And we need cubic meter in the denominator. So clearly it should be the conversion factor. So the 1 is replaced by this one. This one is replaced by this one. So ultimately we will have, you see. So equality will hold because 1 into 1. So 1 and 1 is replaced by the what? The equivalent, this conversion factor and that conversion factor. So the equality will hold because 1 into 1, 13.6 gram per cubic centimeter remain as it is. 13.6 gram by 1. Only dimensionally it will be changed. This 1 is replaced by 1 kg by 1000 gram and this one is replaced by 10 to the power 6 cubic centimeter by 1 cubic meter. So you see gram cancel, cubic centimeter cancel. So we'll have kg per cubic meter and clearly you see 13.6 10 to the power 3 kg per cubic meter. This is the factor level method.